Alrighty guys, got one more problem here for you. So this one says, believe it or not, Mr. Weiss has a life outside of being the world's most monotone physics teacher. That is true, I can confirm that. He's a slightly above average pinball player. Over the weekend, Mr. Weiss plays the most fun pinball game ever. The game is completely vertical, alright, so only in the Y direction. Pinball is an old but fun game and relies heavily on the laws of physics. The game begins with a fun spring that is pulled back and fired at a fun ball. The ball then is launched to a maximum height, so that sounds like apex. And it says, assume Mr. Weiss pulls the spring back 10 centimeters. So 10 centimeters is 0.1 meters. That's important. And hits the 1.2 kilogram pinball, so that would be our mass. The ball flies to a maximum height, so this would be h, of 10 meters. Doesn't that sound like fun? How much energy is there when the spring is pulled back? All the way at the beginning. So let's go ahead and figure that out. So the spring is compressed in the beginning. So if the spring is compressed, it looks like this. And that means that the ball is not moving in the beginning. So the initial kinetic energy would be 0. And I would argue that the height is also 0. And there's no mention of air resistance or friction, so thermal is also 0. Therefore, all of our energy goes to EPE. So we want to figure out what that EPE is. We know that EPE is equal to 1/2 kx squared. So all we have to do here is just plug in our numbers. We know that x is 0.1 meters because that's talking about how far the spring is pulled back, and k, we don't have k. So unfortunately, we can't solve for EP first. We got to solve for something else. So let's move on to the next step. The spring is no longer compressed and the height is considered 0. The ball is still moving at this point. So the height is still 0 because the ball hasn't moved. The spring is no longer compressed, so EPE is 0, and the thermal is 0. So now we're looking for a velocity. Well, if we look up here, we don't have any initial velocity. So we can't answer that yet either. So we actually need to approach this problem slightly different. It doesn't tell us to solve for anything at the maximum height. All it tells us to do is to solve for it when the spring's compressed and the ball is here, and then when the spring is no longer compressed and the ball is still there. What we need to do, though, is we need to solve for when the spring is no longer compressed and the ball is at its maximum height here. And we know the maximum height to be 10 meters, and we know that when the ball is at that maximum height, it has 0 velocity. So all of our energy at that maximum height should be GP. So let's go ahead and solve for GPE at the apex. So GPE apex. And we know that's equal to mass times gravity times height, where we said the mass of the ball was 1.2 kilograms. The height of the ball was 10 meters, and gravity is on Earth, which is 9.8. So all we need to do is plug those numbers in. So we find out that GPE should be equal to 1.2 times 9.8 times 10. If I plug that into my calculator, I should end up with a GPE of 117.6 joules. So this GPE is our total energy, because at the apex, the only energy we should have is GPE, because the ball is no longer moving, the spring is not compressed, and we're ignoring thermal. Therefore, we can take this energy and plop it down here as our kinetic that we start with, and also our elastic potential energy that we begin with as well. Now that we have these two, it's super easy. We can go ahead and solve for the maximum velocity and the spring constant. The maximum velocity is going to happen when the kinetic energy is at a max, which is at this point here. So to solve for that, I know that kinetic energy is equal to 1/2 mv squared. Again, to solve for v, I'm going to multiply by 2, divide by m, and then square root it, just like we've been doing in the other problems. So we have 2 ke divided by m, and then the square root of that is equal to velocity. We know that our kinetic energy, just like we said, should be 117.6, and our mass that we just used previously is 1.2. So if I go ahead, plug my numbers in and solve, I find out that my velocity for this object should be 14 meters per second. Now that I have the velocity, I can just work my way to the next step. The next step is the spring constant. So in order to solve for the spring constant, I'm going to need EPE. And I know that EPE is equal to 1/2 kx squared. So you're going to notice that kinetic energy and EPE have basically the same equation, just different variables. I'm solving for k here, so I have to manipulate it again. I'm going to multiply 2 and then divide by x squared to get k by itself. So I end up with EPE times 2 divided by x squared is equal to k. And we said x is the distance stretched, and the distance stretched is 10 centimeters, but x is supposed to be in meters, so we're going to convert that. So we have x is equal to 0.1 meters. Plug our numbers in, and we find out that our k value should be equal to 23,520. And again, k should be newtons over meters. So go ahead and plug that in here. We said it was 23,520. So just to wrap this up, when you guys have a problem like this and it seems like nothing's working, maybe try solving for something that it hasn't asked you to solve for. Or always think about the apex, because we know at the apex, all we have is GPE.